NASA is back in communication with a spacecraft that's unimaginably far away. Launched more than 46 years ago, Voyager 1 is now beyond the dwarf planet Pluto and outside of our solar system more than 15 billion miles away.
Hey there, space enthusiasts. Get ready to blast off into the cosmos with us. Welcome to Spaceverse, where the universe is our playground and curiosity knows no bounds. Join us on an interstellar adventure as we dive into the depths of space, uncovering its mysteries and marvels. From the secrets of black holes to the landscapes of alien worlds, we're here to ignite your imagination and expand your cosmic horizons. With mind-blowing visuals, expert insights, and the thrill of exploration, Spaceverse is here to get to the ultimate cosmic journey. So strap in, hit that subscribe button, and let's embark on an epic voyage together into the vast unknown of Spaceverse. This is what NASA's official Voyager account tweeted recently to celebrate Voyager 1's return. After 5 months of receiving unintelligible signals, NASA has finally decoded a coherent message from interstellar space. Considering everything that has transpired in the past 5 months, this achievement is nothing short of a triumph. Voyager 1, located 15 billion miles away, holds the record as the farthest human-made object in space. The spacecraft has been voyaging for nearly half a century. However, a glitch causing a series of confusing communication patterns made the last 5 months particularly stressful in Voyager's history. NASA engineers tackling the issue faced 2 significant challenges. Firstly, the spacecraft, constructed over 5 decades ago by now retired individuals, required the current team to meticulously sift through old documents to understand its operation. Secondly, despite numerous software updates in recent decades, the technology remains severely outdated. To put it into perspective, while a modern cell phone can process over 100 billion instructions per second, Voyager's computers manage just 8,000. But what exactly was the glitch that delayed resolution for so long? Why did the conventional method of turning the system on and off fail to rectify it? Lastly, and perhaps most importantly, has the issue been fully resolved, or are there lingering concerns that still need attention? Similar to computers on Earth, the Voyager spacecraft communicates with us using the binary system, which employs only 2 numbers, 0 and 1, to represent various types of information. Each 0 or 1, known as a bit, can denote anything from numerical data and letters to more intricate data like images or audio. On Voyager 1, it has been determined that the glitch stemmed from one of its main computers, specifically the Flight Data System or FDS. The FDS is tasked with gathering 2 types of information from the spacecraft: data from scientific instruments for studying the universe, and data concerning the spacecraft's health to verify if all systems are functioning correctly. Once collected in binary format, the FDS processes and consolidates this data into a unified package. This package is then transmitted to the computer command system, which houses the telemetry modulation unit. The TMU modulates the binary data onto a carrier signal for transmission to Earth. Afterward, the TMU sends these signals via the Deep Space Network, a network of large radio antennas strategically positioned around the Earth in places like California, Spain, and Australia. The DSN ensures continuous communication with various spacecraft as the Earth rotates. Upon reception, the binary data undergo further processing at data centers, where they are converted into human-readable formats such as numerical values, graphs, or images, essential for analysis and research. Since its launch, the spacecraft has been sharing information in this manner. However, over the past few months, instead of transmitting the usual blend of scientific data and spacecraft health updates, the TMU began sending a perplexing and repetitive sequence of 1s and 0s that lacked coherence. It became evident that the FDS was mishandling the information, resulting in erroneous data reaching the TMU and subsequently transmitting the logical binary messages back to Earth. Typically, when faced with such issues, the initial solution involves restarting the FDS by powering it off and on again. This approach often resolves most technical problems on Earth and in space. For instance, in 2010, when Voyager 2 encountered a similar issue due to a bit flip, executing a memory reset command for the FDS successfully rectified the problem. This on-off procedure also addressed a glitch with the Hubble Space Telescope some years ago. Applying the same strategy, a reset was attempted on the FDS in this case, but it failed to resolve the persistent issue upon system reboot. Consequently, engineers and scientists embarked on devising more robust solutions. The Voyager team made a breakthrough after months of meticulous troubleshooting, pinpointing a faulty chip as the root cause of their challenges. But how did they uncover this? In March 2024, the mission team initiated what's known as a poke command to the FDS. A poke command is a direct method for altering the values stored at specific memory addresses in a computer. Typically used for low-level operations, especially in older computer systems, poke allows programmers to interact directly with hardware by modifying values stored in memory. For instance, in systems like the Commodore 64, altering text color involves using poke commands where each color corresponds to a specific number at a designated memory address. For example, executing poke 646,7 changes text color to yellow, with 646 indicating the memory address for text color and 7 representing yellow. This capability grants programmers precise control over hardware features, facilitating exact adjustments to functionality. Returning to Voyager 1, the poke command empowered engineers to direct the system to employ different readout sequences within its software packages to resolve the issue. Subsequently, following a 22.5-hour wait for the FDS response, engineers observed unusual readings from a system component. These readings appeared improperly formatted. Through careful interpretation of these perplexing signals, the engineers obtained a comprehensive system memory readout. By comparing this data with pre-issue records, the Voyager team identified the source of corruption. Approximately 3% of the computer's memory was compromised. Specifically, a chip responsible for storing part of the FDS memory and crucial software code was found defective. This explained why conventional restarts in November 2023 were ineffective. Given the impossibility of repairing the chip aboard Voyager 1, which is billions of miles away from Earth, the team opted to relocate the affected code to another section of the FDS memory. However, due to size limitations, they had to divide the problematic code into smaller pieces and distribute them across different parts of the FDS. This was a complex process requiring modifications to ensure compatibility and updating references to the code's new locations within the FDS memory. Initially, on April 18th, the team isolated and moved the code responsible for managing the spacecraft's engineering data to a new memory location within the FDS. Despite the considerable time delay of approximately 22.5 hours for signals to travel to and from Voyager 1, the wait proved worthwhile. By April 20th, upon receiving a response from the spacecraft, the mission team confirmed the success of their adjustments. For the first time in 5 months, they could monitor Voyager 1's health and operational status, indicating the effectiveness of their solution. Although contact with Voyager 1 was never fully lost, likened to a phone call where one cannot hear the other person, the recent adjustments have restored meaningful communication. However, this marks only the initial phase of their efforts. In the upcoming weeks, the team plans to continue relocating and refining the remaining impacted sections of the FDS software. Once these refinements are completed, Voyager 1 will soon resume transmitting valuable scientific data. These data are crucial as Voyager 1 now explores regions of space less influenced by the Sun, providing insights into cosmic rays and magnetic fields inaccessible by direct study. Despite the increasing difficulty of maintaining contact as Voyager 1 travels farther into space, where signals weaken and take longer to reach Earth, the spacecraft's journey persists. Although it travels aimlessly, in approximately 40,000 years, Voyager 1 will pass near a star named Gliese 445. While this time frame is immense by human standards, it represents a mere moment on the cosmic scale. Voyager 1's time-gathering scientific data is limited. Both Voyagers have explored space for almost 50 years, but their power is expected to fade after 2025. Once they cease functioning, they will drift silently through the Milky Way, possibly indefinitely. Scientists hope they will continue sending data until their 50th mission anniversary. Recently, the James Webb Space Telescope measured the universe's expansion rate, revealing a significant crisis in cosmology. These results challenge our current understanding, suggesting a fundamental flaw in our model of the universe. If you missed this breakthrough, be sure to catch up on this momentous discovery. And that's it. Thanks for joining us on Spaceverse, where we delve into the captivating saga of Voyager 1's resilience and exploration. From overcoming technical hurdles to unlocking cosmic mysteries, we bring you the latest in space exploration and beyond. Subscribe to Spaceverse for more on Voyager 1's journey and other thrilling adventures in the cosmos.